Okay, the rectangular coordinate system. Before we define the rectangular coordinate system, we need to know what a real number line is. Consider the line that stretches to infinity on the right, so it goes to plus infinity, and it stretches to negative infinity on the left. Then any point on this line can be described by one number. We just need to first take an arbitrary point to be the origin. So let's say this is the origin, and this origin is described by the number 0. And we also need to think of a unit. So let's say this is 1 unit. So this point is 1, this is 2, this point would be -1, -2, and so on. So any point on this line can be described by only one number. So for example, if I say the point 3, then you know I am talking about this point. If I say the point -1.5, then you know I am talking about this point. This is the point -1.5. So any point on this line can be described by just one number. But if I, instead of just one line, if I have a two-dimensional space like this board I am working on, if I want to describe any point on this board, then one real number line does not work, and what we need is the right angle intersection of two real number lines, a horizontal one, which is called the x-axis, and a vertical one, which is called the y-axis. The point of intersection between these two real number lines is the point 0, 0, which is called the origin. So the origin is the point 0, 0. Now, any point on this two-dimensional space, which is also called the Cartesian plane or the rectangular coordinate system, can be described with an ordered pair of numbers, x and y. So for example, if I go 1 unit to the right from the origin and 2 units up, I reach this point, which can be described by 1, 2. 1 for x because I moved 1 unit to the right, and 2 for y because I moved 2 units up. Or if I move 1, 2, 3 units to the left and 1 unit up, then I reach the point -3 and 1. If I move 2 to the left and 3 down, I reach the point -2 and -3. And if I move 1, 2, 3, 4, 5 to the right and 1 down, I reach the point 5 and -1. So now you can see any point on this board can be represented with an ordered pair of numbers, x and y. X is called the x coordinate of the point and y is called the y coordinate of the point. As you can see, this coordinate system partitions the whole space into 4 parts. Part 1, or quadrant 1, another name for that is quadrant. Quadrant 2, the third quadrant, and the fourth quadrant. So any point in the first quadrant has a positive x coordinate and a positive y coordinate, because in order to reach a point here you need to move to the right and up. Any point in the second quadrant has a negative x and a positive y, because as you can see, in order to be here you need to move left and up. And any point in the third quadrant has a negative x and a negative y, because in order to be here you need to move left and down. And any point in the fourth quadrant has a positive x and a negative y, because in order to be here you need to move right and down. The points that are on the x-axis, they always have a 0 y coordinate. For example, this point here on the x-axis is the point 2 and 0. This point here on the x-axis is the point 5 and 0. So as you can see, all the points on the x-axis, they have a 0 for y coordinate. And all the points on the y-axis, they have a 0 x coordinate. For example, this point here is the point 0 and negative 2, because you're not moving to the left or right, you're just moving down. So this is the point 0 and negative 2. Or for example, this point here is the point 0 and 3, because you're just moving up. So all the points on the x-axis have a 0 for the y coordinate, and all the points on the y-axis, they have a 0 for the x coordinate. Okay, now let's look at the distance formula, the distance between 2 points on the xy plane. So again, consider this rectangular coordinate system. Let's say this is the point x1, y1, and this is the point x2, y2, and you're interested in the distance between these 2 points, so the length of this line segment. The formula would be, so let's say that the points are A and B. Point A, point B. Point A is x1, y1, and point B is x2, y2. Then the distance between these 2 points is given by this formula: x2 minus x1 squared plus y2 minus y1 squared. The reason for that is you can consider this right triangle here, and then in a right triangle we have the Pythagorean theorem, which says this length is equal radical this plus this. And if you look at this side here, the length of this side equals the length of this line segment, which is x2 minus x1. And this side here is the same length as this line segment between y1 and y2, so the length of this side is just y2 minus y1. So for that reason, this side here, or the hypotenuse to the power of 2, would be this to the power of 2 plus this to the power of 2. In other words, the hypotenuse itself would be a radical this to the power of 2 plus this to the power of 2. Okay, let's look at an example. If A is negative 3 and 4, and B is 8 and 1. Okay, now you want to know what's the distance between A and B. Use the formula. It doesn't matter which one you take to be the first point and which one to be the second point. The distance, let's say this is the first point and this is the second point, would be radical x2 minus x1. That gives me 8 minus 3 to the power of 2 plus y2 minus y1, that's 1 minus 4 to the power of 2. That gives me radical, this is 11 to the power of 2, 121, plus this is negative 3 to the power of 2, which is just 9. Negative 3 to the power of 2, 9. So the distance between the 2 points is radical 130. One other formula from this section of the book is the midpoint. So what is the midpoint? If I have these 2 points, let's say point A and point B, and I connect them, I have the line segment AB, and then this point here, which is right in the middle, is called the midpoint. Let's call it M. And if you have the coordinates of A and B, if for example this is x1, y1, and this is x2, y2, then the formula for the midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. So in order to get the midpoint, you just need to find the average of the x coordinates of A and B and the average of the y coordinates of A and B. For example, consider the points 5 and 2 and the point -1 and -4. The midpoint between these 2 points, let's call it M, is 5 minus 1 over 2 and 2 minus 4 over 2. I'm just adding up 5 and -1 divided by 2, adding up 2 and -4 divided by 2. That gives me, this is 4 over 2, just 2. This is -2 over 2, which is -1. So this is the midpoint between these 2 given points. Okay, let's look at one word problem. It says find the point or points on the y-axis that are at a distance 5 from the point 3, 5. Okay, so we have the point 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. We have the point 3, 5. And we are interested in finding 2 points on the y-axis such that the distance between that point and this given point is exactly 5 units. First of all, we know that the point that we are looking for is on the y-axis. Since it's on the y-axis, we know that the x coordinate of that point is just 0. So we are looking for a point that has the form 0, y. Because all the points that are on the y-axis have the form 0, and a number y. And the other thing that we know is that distance between the given point and the point we are looking for is exactly 5. So let's use the formula of the distance between these 2 points. The distance is radical 0 minus 3 to the power of 2 plus y minus 5 to the power of 2. And we want this distance to be exactly 5. So as you can see, this is just a radical equation in only one unknown y that we have to solve. So here we have 9 plus y squared minus 10y plus 25 equals, so we raise both sides to the power of 2 equals 25. Then this cancels this, so we have y squared minus 10y plus 9 is 0. This can be solved by factoring. This is y minus 1 times y minus 9 equals 0, and this implies that y is either 1 or 9. Okay, so we have 2 points, the point 0 and 1 and the point 0 and 9. Both 0, 1 and 0, 9 are at a distance 5 from the given point. So this point 0, 1 and 0, 9. So 5, 6, 7, 8, 9, it's around here. Both points are at a distance 5 from the given point. Okay, and that's it for rectangular coordinate system, the distance formula, and the midpoint formula.